part of the HPC team in Ghent. So part of the team who's organizing the dev room today. And he's going to introduce EasyBuild.
I already got a very good introduction to the people who saw the previous talk about environment modules. People who are not familiar to the team, we're from Ghent University, which high performance computing team. It's a central contact for high performance computing at Ghent University. So we have big computing infrastructure, 7 clusters at the moment, and one shared system between the Flemish universities. Top tier 1 was number 119 in top 500 in 2012. There's 8 people on the team, they're all here today. So, yeah, one big part of the work at our team is to install the scientific software for scientists. They want to do simulations, they want to do their research, and they need the software to run in the cluster. They can't install it themselves. They ask us to do this. And of course, one of the models is automate everything. So we have 7 clusters. We're not going to install manually the software on each cluster again and again. We automate the build procedure. And so EasyBuild grew a need for this. As in the previous talk, Aaron explained, building scientific software is really fun for us. Very good documentation. Everything works flawlessly, of course. No, not the case. As he said, it's written for people who need it to work for themselves. They use hard-coded settings, like their fonts are all hard-coded. So if you want to use the environment modules, as we saw earlier, you have to patch it, because expect these libraries to get downfound, but then you need to use the environment properly set up. So it's very time consuming, also for other HPC teams. And the tools that were available are lacking. So we prefer to build everything from source. So the installation is not just downloading the RPM and installing it. It's high performance computing, so you want to use, with a CPU, you want to use all the instructions it has to compile for your CPU. And to do that for scientific software, you say, yeah, use Gentoo. Well, almost none of the packages that these researchers want are already in there, so you have to do it yourself. And then why restrict yourself to one operating system? So they're hard to. There are tools out there. Other institutes that make just a list of bash scripts. They just run it. It's bash, 10,000 of lines. Not really maintainable. Or just standalone. Start a new thing every time, but they don't try to reuse anything. Or very OS dependent, as I said, of course. And some projects, they know they're really hard to install, like Dolphin. They have a tool called Dorsal, which is again bash scripts, reuse. Well, some good news, it works, but only for software. It's really hard to add everything to it. So, as I said, yeah, not all of them are packaged. And just, yeah, make an RPM, yes, but then the other distros, people use another environment, you have to redo the work again. Also, yeah, like current tools, current OS, it's really hard to install multiple versions of the program, because this is often a big requirement. Researchers all use the same system. Researcher A wants version 1.0. Researcher 2 found out there's new features in 1.2, so he wants to use that one. They both have to be available in the system. And you compile them with different compilers. You compile with Intel compiler, GCC, CI, because sometimes different compilers give different results, or you want to test which one generates the most performance code, and you did there. For example, you would build with everything with Intel, because mostly that's the best performance, but GCC, the researchers also want to use the same thing they have on their laptop, and then they compile it with GCC. So we want to make both available. say you can switch KPI stacks, change the master kernels. So what we wanted was a flexible framework, so we wanted other people to be able to join us in the effort and add features easily, so and to be flexible, modular, pluggable. So a big part of this, reproducible builds, because the scientists, they need to be able to reproduce their experiments. So if they can build it in one cluster, but then the system is gone after 2 years, but they want to do a little thing again, well, we try to make install the same version of the software and all its dependencies to the same version. Already explained coexistence of different versions. A big deal is also the sharing of the effort. So we put a lot of effort in it, and we want to share it with other teams all over the world. Because if we share it with them, hopefully they share back, and in the future maybe we can easily install something without having to do much effort. Of course, everything has to be fully automated, and dependency resolution, because we install dependencies. So we don't want to build everything one by one, we just say build this and all its dependencies. So that's what EasyBuild does. It's written in Python, so people can use it because we like Python. We use it for all our tools. EasyBuild has been developed in-house for 2.5 years before we made it public. It was completely rewritten with good practices in mind and released as open source in 2012. Then we finally got the state API in November. And since then we're doing semi-monthly releases, not monthly. And we're working on this continuously because our users keep requesting us to install software. Other teams are requesting to add features. So we try to release frequently. We have various contributors who contribute to EasyBuild, so mostly HPC teams and other universities or institutes. Also people from NVIDIA helped us with the NVIDIA support. They're running it on their own test clusters. We don't have GPUs ourselves, but they try to run it, and there's also other people from scientists. So how does it work? We distribute EasyBuild and what we call easy configs, so what we know as recipes. Call it the .pp file. So this is the is commanded, and you give it the file minus R to do recursive build all the time. So what does this file contains? It contains the name of the software, where can be downloaded, short description, version, list of its dependencies, and what toolchain you want to build it with. So if you run this command, after installing EasyBuild, this will try to download all the sources you can find, maybe some mirrors are down or something, or you don't have anything else, you can put the sources in for applications to pick them up. So this will build first, download the version of GCC, and compile GCC from source again, because we want it to be reproducible. So we know it people try to be very helpful. They give you just one binary. Sometimes it's closed source programs as well, which just give you binary and ask you questions. There's no way to patch it when you're around it. You have to actually answer questions. You have support for that. And replies. Since we have a huge cluster, we have lots of machines to build. So if you have a mission new system, you can just run one command -- job, and we'll use our clusters scheduling software to push all to build a dependency tree. Once that dependency is correct, we push all software into the cluster, start builds. We can 48 hours later, all the software that was available on the old system is now available on the new system. And we try to do comprehensive testing, so we have unit tests, and before every release of EasyBuild, we use the job and we build all the software we build it to see if everything still works as expected. Currently, what we released, 443 packages are in our public repository. With over 3,000 easy configs, so with a lot of different versions, a lot of different chains. This includes a few very hard to build software packages if you have to install them yourself. Over here last year as well, I made a list of all the packages that were in there. Then it was readable. There were about 150, so in 1 year time, we got another 300. For instance, how the modules, how the software is designed for this. So we have the EasyBuild is split into 3 parts. We have the framework, which forms the core of EasyBuild. It provides all of the core functionality, like the commands for patching or pushing to Git. All of this is implemented in the framework. Then we have EasyBlocks. So some software, there's the recipe, but just the download URL and the version is not enough, because by default you configure make install. But of course, not all the software uses this. It would be very good if it was. So an EasyBlock is something you specify to do instead of configure make install. This is pure Python module. So this is where you implement the entire build, so instead of documenting it. This can be generic, like for a Python package. First you install Python, and you want to install Kotlin. Then you know how type packages work, you set that to apply. More software specific, so for just one specific software. It's Python, it's object oriented, so usually you only have to implement 1 or 2 functions, and not an entire build procedure, just use code that is already there. And then there's the easy config file, which we call a recipe. Currently there are still text files in Python, but this will change in a new version. So as I said, modular design, dynamically extensible. So if you add these blocks, you don't have to put them somewhere on the right space or put them in the Python path in the right module, and EasyBuild will pick it up. So as I explained, you can have generic EasyBlocks, application specifics. So the framework has some tools to do the interactive commands, unpacking files, applying patches. And there's tool chains. So tool chains in this software compiler and the API command kernel. This allows us to pack the feature in one place and then build an entire software stack with these tools. So we have one for Intel, we have one for GCC, there's one for GCC with CUDA, and so on. So you can pick match your own chain. Of course, it also generates the module files, which is really awesome. If you already have module files and you want to reuse them, maybe you have a different naming scheme, so you can just configure everything. This was added quite recently. We test everything. If you're planning to use it, please also test things if you have new packages. So you have been working hard on actually doing good software. practices to actually but we still need something we do need is better test for the software, so we install the package, but we're not really sure if it's doing what the researcher wants us to do. We ask them to give us an example, but that doesn't always go. There's also no problems with environment module setting an LD library path. If you have a lot of dependencies that become too big, like spraying your storage system, if it has to go through all the directories. So there's solutions for that part, but these are being investigated. Okay, maybe I convinced you, you want to use it. Well, what do you need? Linux, it will work. We test this on Fedora, Debian, CentOS, SLES. So we have a developer using it on a daily basis on OS 10. We have no Windows support planned. This is because there's no environment modules for Windows, so we can't use it. It's not because we can't. By 2.4, so we're running this on some old systems that still have Python 2.4. We support it for now. Not sure for how long, but for now, everything will be written by 2.4. And a C compiler to start your first build of a GCC for the Intel. Installing EasyBuild, well, there's a bootstrap. We'll look into providing RPMs and deb files soon, because that's maybe the easiest way to actually get it installed. You can install EasyBuild with EasyBuild. You can find all of this on the website. Configure it as much as you like. You might try to make it very easy to make your changes. So, if you want to know more, we have a website, we're on GitHub. You can download it from Wi-Fi. We're very active on IRC, channel EasyBuild.Freenode. Follow us on Twitter. Questions you can also follow. Questions?
All right, begin. 2 or 3 minutes for questions.
One package that you mentioned is open for. I tried to build it performance and I couldn't get it to build. One of the things I didn't like was it ships a specific version of GCC. You say you do that. I understand why you do that. Can you say a little bit more about that? Why you do that? I didn't like that. I thought, well, it shows you software is rubbish. You know, it needs a set version of GCC. Whoa.
No, so we do this so we can reproduce the build. So we built it with this version of GCC. Later on, the researcher wants to do this on his laptop. He wants to try the same build. Maybe a different version has a different feature or does something else, so he can actually reproduce the build with the same version. But basically, we build GCC once, and then it'll be used forever. It will be on your system, so you don't have to rebuild it every time. You install it once. If a new version of GCC comes out, you can rebuild all your packages with the newest version, and you leave the old ones in place so the researchers don't get paranoid. Everything just changed, and you leave the old one, and a new version of GCC comes out, you can rebuild it for the people who want to. That's the reason.
I have similar use cases. I've researchers come to use my systems, and they want the latest GCC, but people using our system in production they won't change it. You know, I convert. There's a mechanism in SUSE Linux for putting in extra compilers and extras or something like that. You put it somewhere else in the this sounds even better.
Yeah.
So, if a researcher is creating their own software to run on our machine, should I be recommending to them to create their own EasyBuild modules for their package?
A few of our users have actually done this. They can ask us to install software, we do it, but if they say, here is the EasyBuild tool, it works in EasyBuild, I've added it, then we'll just install it.
A lot of them are working on several different systems, including the National Tier 1 machines as well as that one. Because I'm recommending CMake external project for that kind of thing in a lot of cases, and I'm wondering if that would be a better EasyBuild would be.
Choice, yeah, so not about CMake. But we wrap around CMake, so if they use CMake, by easily configure make install, but if there's a project already using CMake, just wrap around it and also call the CMake. Everything still works.
The sources are stored as anywhere, or if Yes.
So you,
Theoretical storage. Well, when you run all the sources for that,
yes,
some of them might be still old. Right?
exactly. So this is one of the known problems. Sources can be removed from the web. There are some efforts to actually start the sources that we're allowed to distribute, to collect them somewhere on the mirror. There's a project being talked about.
What is external from this? It's just like...
Yeah, that's a separate problem. We're not trying to solve
Is this presentation also on your website?
it. An alternate version of it.
We have a YouTube video as well.
Just on the archiving sources thing, a certain scientific package, which will not be named, changed the sources without changing the version number, just quietly changed it online.
There are several ones that do.
So that's why in the new version we added actually checksum.
Is there
One more question?
is there some sort of repository for the EasyBuild files?
Yes, so they're on a GitHub.
So when you pull the file, you pull the dependencies of the file, or
So currently these are just easy config, so you pull all of them in. They're just plain text on the few lines.
so you have to maintain the local copy of all the configs.
At the moment, yes.
It just gets installed with EasyBuild. So EasyBuild is a framework with easy blocks, so the implementations of the build procedure, and then the specifications.
So we call these examples. So they're known to work, and we try to share them with everyone, but they're considered examples. You can make as many as you want. And if they work, please share them with us.
The last one
Sorry,
is
Peter.
Intersecting with another big theme with FOSDEM, you're packaging up a file tree and packaging modules. Could you make a Docker container out of this? That may next step. I'm talking about code.
I'm sure you probably could, yes. But we're not going to do that.
we haven't looked into it yet, but it's just like basically an RPM or a
Well, you can make a Docker of the applications and ship that and keep it for archaeology. Keep it for discussion walks.
We've been looking into these Docker people talking to them, but not really.
Okay, that's it. Thank you very much, Jens.